Welcome to Study Loop.
Okay, we've got trimethylbutane, and it is 2, 2, 3, trimethylbutane. All right, which of the following is true? Well, let's consider a Newman projection. I'm assuming that Newman projection is going to be down the 2, 3 bond axis. That's the most interesting one. In that case, I like to do a little bit of color coding when I do Newman projections. So in the front, carbon bond up, carbon bond down to the left, carbon bond down to the right, while in the back, we can have a methyl, and hydrogen. Right? And recall that since there are 3 of the same constituents on carbon 2 and 2 of the same constituents on carbon 3, there can't be any stereocenters. So the organization of these groups is arbitrary. That is, a methyl here is exactly equivalent to a methyl there, and I can spin these freely without changing anything. And we need to figure out which of the following. Okay, anyway, so this is the setup of really the most stable conformation, and we can draw the least stable conformation as well. And that would just be with everything overlapping. And really, because there's 3 of the same thing in the front, there's really only one way to draw things. We don't have many equally good or bad ways to draw everything, is what I'm trying to say. Simplifies the problem. Okay, so this is the least stable, and this is the most stable. And in fact, all of the stable configurations are equivalent, and all of the unstable configurations are also equivalent. Like if we plotted them, it would just look like this. Okay. Statement 1, the most stable configuration of the molecule has no torsional strain interactions. Yeah, this is true. Right? Statement 1 is true. Torsional strain is specifically eclipsing strain, right? And at no point in this stable interaction do we have eclipsing. Every interaction is gauche. So A is true. Okay, in B, the least stable conformation has 28 kilojoules per mole of torsional strain energy. Okay, we're going to have to look at a table for this. Okay, so methyl torsional. Methyl eclipsing is 11 kilojoules per mole, so that's 11, and methyl hydrogen is 6, right? So I see 28 altogether. Okay, so B is also true. C, the least stable conformation of the molecule has 22 kilojoules of strain energy. Okay, well, this is actually, okay, so B is not true. B is false. It has 22 kilojoules of strain, but it's not all torsional, right? So recall that methyl interactions are partly torsional and partly steric. right? And so if it totals 28, not all of that can be torsional. Some of it is steric. Okay, so B is false. Tricky one. Okay. The least stable conformation is 22 kilojoules per mole of strain energy. This is also false, right? We know that the total strain is 28, roughly. The most stable conformation of the molecule has two gauche butane interactions with 7.6 kilojoules per mole of strain energy, and that's false, right? Gauche, 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 gauche. Each of those is 3.8 kilojoules per mole. There are far more than two. There are four. So C is also D is also false. A is the only true answer.